All right, guys. In this case, we want to show how to resolve a maximization case where the matrix is unbalanced, and so it's a case of having unbalanced situation, and it's also maximization. So the first thing we're going to do is to do the adjustment part of it, which is squaring the matrix to ensure that we have a a squared matrix. Or you can start from converting the matrix, because these things are not allowed to run. This payoff, profit payoff, are not allowed to run on profit. So, well, we can start by converting this payoff to relative cost, then square the metric, balance the metrics, and then resolve it. So let me quickly start by um, solution. Let me do relative cost so that we at least make the payoffs usable. So we have workman, we have jobs, have one, two, three, we have Bear, Fatima, Ade, and Chidi. So to convert to relative cost is quite simple, and it's just, you know, when you assess the whole table, you identify the highest value, the largest value, and you deduct every other value from it. By so doing, you would have converted to relative cost. So quickly, we have 18 to be the highest value here. We're going to subtract every other value, from 18 to get the relative costs. So 18 minus 10 will give me 8. 18 minus 9 will give me 9. 18 minus 6 will be 12. 18 minus 8 will also give me 10. 18 minus 8 will give me 10. Yeah. Then 18 minus 15, we have 3. 0, 18 by itself, then we have 4. 18 minus 16 is 2. Then 18 minus 9, 9, this by this, 13. 18 minus 3, 15. Then 18 minus 6 is 12. So having converted to relative cost, the next will now be to square the matrix, and we'll now take other steps in Hungarian method. So I have step 2. Squaring the matrix. So we have jobs, workman, have 1, 2, 3, dummy. Then we have Bere, we have Fatima, Ade, and Chidi. So all these things will come back. We have 8, 9, 12, 10, 3042, 304, and 2, 9, 13, 9, 13, 15, 12, and of course 0 will be, dummies will be 0, 0, 0, and 0. Alright, this is now 4 by 4 matrix. We have converted the profit payoff to relative cost, and with relative cost we have moved to squaring the metric. So we won't be needing this table for now, because when we'll be computing our final profit, we'll come back to this table, not this one. So we're done with this. We can clean this thing off at this point. So the next will be the which is our colon opportunity cost table. So we have 1, 2, 3, 4. I have Ebere, Fatima, Ade, and Chidi. So now we're doing our colon opportunity cost matrix. We'll be identifying the smallest value in each of the column, and deduct same from the column. So for column number 1, our smallest value here is 8. So 8 minus itself will have 0. 9 minus 8 will give us 1. 12 minus 8 is 4. Then 10 minus 8 is 2. Here there is presence of 0, so every value here returns. 3 minus 0 will give us 3. 0 minus itself 0, 4, and 2. And here the smallest value here is 9. 9 minus itself is 0. 13 minus 9, I'll have 4. I'll have 4. 15 minus 9 will be 6. Then 12 minus 9 will be 3. I have 0, 0, 0, and of course 0. So is our colon opportunity cost matrix. So we're going to do, from this colon opportunity cost matrix, we're going to do our row opportunity cost table, that is also called total. So I'm going to clean this. Clean this, and we have this is now 4 total opportunity cost table. Have 1, 2, 3, and 4. So these are of course our row. I'm going to go row wise. So that's 0, 0, 0 in a better row. So we're going to return it. So we have 0, 3, 0, 0. There's also 0 here, 0 here. So we have 1, 0, 4, and 0. Then there's 0 in the Ade row. So we have 4, 4, 6, and 0. Then there is 0 in Chidi row. So we have 2, 2, 3, and 0. Alright, so having done this, we're done with this now. We can clean this off. So let's step 3 go, so that we can now test for optimality clearly. So the next point will be to test for optimality, and that is done by covering the largest number of zeros, as we've done in our previous videos. So we have 4 by 4 matrix. Is there any place we have 4 0 lined up? Yes, in column number 4 for job. I can see 1, 2, 3, 4. That's vertical, non-diagonal. So I will link it. Any other place with 4 zeros, either in row or column? No. Another 3 zeros? No, but I can see 2 zeros here. So I have to go this way. Any other 0? No. Yes, I can see 0 here. In Fatima row, I can also link it. So I have 1, 2, and 3 lines covering the zeros, and we have a 4 by 4 matrix, which means that we cannot get an optimal assignment from this. So we need to revise our solution for the sake of improvement. So how do we improve? This 1, 2, 3, 4, 5, 6 values are not touched by the lines at all. So we're going to be identifying the smallest value from this 1, 2, 3, 4, 5, and 6, and deduct it from all of them, then add them to the values that lie at intersection. So what revision does for us is to create additional zeros, and of course to redistribute the zeros, to reposition the zeros, to see, to help us find optimal assignment schedule. So we are going to deduct 2, which is the smallest value from this. Yeah, 2 minus 2 minus 2 minus 2 plus 2 at intersection plus 2 at intersection. So step 5, we call this revision. And this is our job. Okay, here are jobs, and we have 1, 2, 3, and 4. We have a workman. We have a bere party, ma, Ade, and Chidi. Alright, so we're going to bring the values here now. This 0 that the lines merely touched is coming back. Same with 3, same with 0. Then we bring 2 back here. So we'll have 0, 3, 0, and 2. For row Fatima, we'll have 1, 0, 4, and 2. 1, 0, 4, and 2. Then for Ade, 4 minus 2 will give us 2. 4 minus 2 again 2. 6 minus 2, 4. And this 0 will simply come back. Then for Chidi, we have 0, 0, 0, 0, 1, and there, of course, 0. Alright, now we have been able to redistribute the 0 by the word of revision. So the next will be to check if you can get 4 lines to cover all the zeros lying non-diagonally. Now I can see 3 zeros here in row Chidi. There is no place that will have 4 zeros at this point. I can see 3 zeros here. I can also see 2 zeros here. Then I have this one. I also have this one. So this is we'll link these zeros first. Then we'll link this 0. And this 0 will be alone. This one is the alone. So I'm going to link them too. And this is this. So I have 4 lines covering the 4 zeros, which means that we can attain optimality with this. So the next will be to make our assignment proper. So we will have to start from the point where there is a 1, 0 in row and then column. If there is none, we move to 1 and 2, where we have 1, 0 maybe in row and maybe 2 zeros in column, and we progress from there. So I can see this 0. It is alone column wise and it has 2 here. Since there is no 0 that stands alone in row and column, so this 0 is alone here. So this is alone here. It is alone in row and it has 2 here. And this column one is alone here and it has 2 here. So it has to take. Okay. So having given this man, it has killed this 0. And having given this man, it has killed this 0. And having given this man, it has also killed this 0. So we can now give this man, because this will now be alone. This one will now be, will be 0. This one cannot take any assignment now. So this one can take. And also this one at this point, of course, is alone. Colon Y. Yeah, we should start from here. This one is alone. Ade is alone in row, but in colon it has 2. So Ade should take here. And of course, at this point, the only one left is Chidi, which also should take here. So now the optimal assignment schedule. The optimal assignment schedule can bring it here. We should now crest or label step 6, the optimal assignment. Schedule. Okay. Will be workman here. You have jobs. Then we have cost, profit. Don't forget, it's a combination of a unbalanced case and a maximization case. So for Ebere, which is number 1, workman, should take job 3. So we're coming here to take the profit. So Ebere should take job 3, that is 9. Okay. Then Fatima will take Fatima will take job 2. Fatima will take a job. Sorry, Ebere will take job 3. Job 3, and it is 9. Sorry about that mix up. Then Fatima will take a job 2. We'll take job 2, and it is 18. The profit will be 18 naira. Then Ade will take the 4th one, which is the dummy. They will take a dummy. It's 4. It's the dummy. The cost is 0. While Chidi will take a 1, job 1, and it is 8. So the total profit will be 18 plus 9 plus 18 will be 27. 27 plus 8 will be 35. We'll be having 35 naira, maybe 1,000 or whatever, as the total profit for the assignment. So Ebere should go to job 3 with the profit of 9, Fatima 2, the profit of 18, and Chidi that they shouldn't get because it's assigned to dummy. Then Chidi will go to job 1 with a profit of 8, and the total profit will be 35 naira, as the case may be. Thank you, and see you in our next video.